What are the skills that are most important for the future?
Mm.
We can debate to what extent we need to learn the basics. Personally, I think that, for example, thinking how to code basic computer science, etc., is going to be more important than ever.
Agreed.
I mean, I always thought that computer science is not learning a language, it's
Not
learning
typing
how
keys,
to
it's how to think.
think.
Yep.
So in a way, it's going to be more important than ever for the same reason that math is important even when calculators became a commodity.
Hey everyone, how's it going? Welcome back to Release Notes. My name is Logan Kilpatrick. I'm on the Google DeepMind team. Today, I'm joined by Yossi, who leads the Google research team. I'm super excited, Yossi. We were just talking off camera about sort of the incredible breadth of stuff that GR is doing. So I'm going to ramble off a bunch of things and then add anything that I'm missing. Earth AI, planetary intelligence, MedGemma, flood modeling, co-scientist, empirical research assistant, FireSat, Learn LM, new model architectures, LLM efficiencies like speculative decoding, new privacy technologies, generative UI, multilingual advancements, market algorithms, weather next, not to mention all the stuff we're doing in quantum, which is just an incredible breadth. And I'm super excited for this conversation. Maybe actually you can start like with all that context of just the crazy breadth of what GR is doing. What is the mission? What is the task that you have and the team has?
Yeah, first, of course, there are more things that we could list here, but
Let's add them to the list.
this is first the most exciting time to be in technology and the most exciting time to do research. Mission really is to make the impossible possible. Essentially looking into what could make a difference. What is the next thing that could actually make a big difference on reality and requires actually to move the state of the art. Essentially driving the breakthrough research and applying it to reality. Something I like to call the magic cycle of research. It's a cycle, by the way, because once we bring it to reality, it actually creates the next question. So many of the things that currently we're so proud of are actually started out by actually asking a question and making some progress and having research and publishing it and then applying it and asking the next question. It's really a cycle that is pretty magical. It's something that I was always excited about. What we see now is that this is accelerating. This is faster than ever, broader than ever. In fact, with AI, both the research itself is accelerating and we're actually having our share and actually help it accelerate.
Yeah.
I'm sure we'll talk about it.
Yeah.
And then also translating it to reality is also quite exciting. And one important characteristic of Google research is that we're both doing the transformative research, the breakthrough research, but also the same organizations, same teams are also working on bringing it to reality to have impact on products, on science, on society. When we look historically, actually, some of the greatest mathematicians, scientists were actually motivated by these kind of questions. In many cases, they were actually very much doing it, right? I mean, Alan Turing, one of my heroes, all-time heroes, was not only setting foundations for computer science, he also built a computer, he ran Enigma. He was also asking questions about AI, setting up, of course, the famous Turing test. So I think this is actually the biggest opportunity that we have. And today, that's why I'm thinking that today is really the golden age of research. Never before we could actually have this kind of opportunity to both ask these questions, drive them, and then have them impact on reality.
I love that. You need to tweet from the GR handle, just like it's the golden age of research every day, and then just like sort of hit this point home for everyone. Because I think you're 100% right about this. Maybe we should sort of go into like what's enabling that golden
Sure.
age of research and the work that your team actually is doing in GR in order to make that golden age of research actually possible.
First, perhaps also worth noting that the scope of the work, because Google is touching so many aspects of technology and products and life, the scope is really broad, as you highlighted. I mean, it's anything from foundational machine learning and algorithms to systems, to building a quantum computer, to advancing AI, to advancing foundations of generative AI models, to applying AI to health, to education, to climate, and so forth. And again, this is in order to really, in all of them, have impact on things that we care about, on products, on science, on society. I'm really excited about the acceleration. What enables us to even further accelerate both the research and the magic cycle itself is how we're actually bringing together, building bigger platforms and using the AI as an accelerator on its own.
Yeah.
So, for example, on the platform side, we already have many models for geospatial over the years, and for reasons actually that are on their own already life-saving, such as flood prediction, working together on weather next between GR and GDM, storm prediction, another important area. But taking all these models, including also various remote sensing foundational models and others, and at some point asking ourselves, how can we actually bring them together as one platform and put AI as an agentic layer on top of that? We call it Google Earth AI. This has so many applications for societal impact, of course, public health, crisis resilience, also business, because obviously many care about planetary questions as they relate to their business. We can actually then accelerate the work of others because they can build on that. We can now unlock new opportunities that never before possible, including, by the way, recently a paper published in Nature by researchers from Harvard, Boston Children's Hospital, and Mount Sinai about measles vaccination in the US and actually analyzing it in a zip code level by building on Earth AI. Think about the health space. We've been working for years on driving many health AI kind of initiatives, but also importantly, at some point we ask ourselves, can we actually take some of our greatest models, put them on Gemma, call it MedGemma, on an open platform for health models, we call it high def. MedGemma that we released last year now has more than 5 million downloads.
People love MedGemma. I get pings all the time from people in the ecosystem who are like solving all types of interesting problems, and they're like so thankful that I'm sure you get even more of those comments. It's crazy.
Yeah, 5 million downloads, and we have all these thousands of applications that we learn about. But quite often, actually, what we get excited about is hearing those stories about how it saves lives.
Yeah.
Just recently heard one from Uganda about how a mother and baby were saved actually by somebody using an application based on MedGemma, actually without even internet connection. So
I think we have a video of this. I haven't seen this video, but I heard this story, so I'd love to watch. This is a perfect segue in order to see it happen.
For us, it's existential to build offline because we know the connectivity in the villages is low, there is no internet. So you have to balance what the African communities have and what the best frontier intelligence has, and you merge them to work for your communities.
There was a moment with Gemma 4 where the limitations felt like they had disappeared. We were actually amazed with what it could do.
For the first time, a model had the multimodality aspect. It could be agentic, and these are things that are central to anyone who is developing for the African market.
I had a mother in labor, fed in the information, and it gave me a provisional diagnosis of eclampsia. And I managed my mother. My mother delivered well and is doing well. The app is being used on a daily basis, and it has really tried to help us reduce on the maternal mortality rate.
To me, it's personal because at least I've known family members who have lost life, and building systems that can help others or save a life is core to our mission.
We think that it's a statement that frontier-level AI can actually be done in Kampala, that you can be able to actually develop these systems for your communities without necessarily being a huge lab.
We've seen that AI can be used for impact. It can be used to uplift communities, it can be used to preserve cultures, and it can be used for good.
I love that.
It's a reminder at the end of the day, why are we doing what we're doing? When I ask people about what makes you excited, it's a combination of working with the smartest people on the most advanced technology in pretty amazing company that you have all these products and outreach. But at the end of the day, it's really also having impact on people.
Yeah.
And this is one story that we hear about, but this is representing so many other stories that we're not even aware of. So to me, actually, that's kind of one of the amazing opportunities that we have as actually not only drive research, build technology, but actually also have it helpful to people in a very profound way. And it actually has multiple aspects. One is about how to make it helpful to obviously the patient, but also think about the empowerment that it gives the healthcare worker.
Yeah.
So this notion of empowerment to healthcare workers, to teachers, to business people, to scientists is, to me, one of the most exciting aspects of AI. I think about it as AI is an amplifier of human ingenuity. And I'm sure we'll talk more about how we're doing it in science, which is perhaps the most exciting frontier in fact of where we're making progress on.
Yeah. I think one more interesting thread on the sort of planetary intelligence bit that you mentioned before was like actually through this lens of empowering these sort of groups who sort of wouldn't have otherwise had access to this information or the means. You imagine the like, and I'm sure you see lots of these examples come in, but the farmer who's like trying to understand how weather that is affecting, or like a small farmer somewhere where they're not like a giant commercial farm, and they're trying to understand how like weather patterns are affecting their farms and stuff like that. I think historically you would not, and my assumption is those folks like wouldn't have been the users of some of these like really domain specific models that we were creating. They could potentially be a consumer, a user of, the AI system that brings it all together and does it in a way that's like conversational, and they can just like ask their question in human English and not need to like, have a deep domain expertise of how the models work and all that stuff.
And just imagine that you're talking about every single farmer is the whole world. With our technology of neural GCM, which helps with weather, and collaboration with the University of Chicago, we actually helped provide warnings to 38 million farmers
It's crazy.
in India.
Yeah. And actually, for folks who don't know, I just saw this the other day. There's 130 plus million farmers in India, which is just a mind-boggling. Not like, so you think of it like, and I say that to say that sometimes I think the user population of some of these tools, my bias is to think that it's small. And then you think about India and you think that like actually the tool that helps a farmer is 138 million people, which is a massive group of folks.
One of our missions is really to make the impossible possible on things that matter.
Yeah.
My personal experience actually watching a nearby fire 15 years ago got me into understanding how important it is to get timely information, which later actually led me to taking on and lead what we call crisis resilience, launching in search SOS alerts, which now had billions of views on natural disasters and COVID and other things. We launched it actually about 10 years ago. And at the time I discovered that this is all great, we're very helpful. Actually got some notes about various incidents that people say, hey, thanks for doing it, this saved our lives. But discovered also that the most devastating natural disasters in terms of people impact, which are floods, were not helpful. Because in order to be helpful, you need to actually warn people ahead of the flood. And in fact, I remember going to India, to Bihar, getting to a village that was hit by flood just a few days before, overnight, and a few people perished. And there's also always this personal story, because there were 3 young men who actually saved quite a few people overnight, swimming with them to safety. Seeing the villagers, seeing the aftermath, the entire village more or less covered with water, you realize, what we're missing is a warning. And then I had conversation with many experts, hydrology, flood experts. Everybody were telling me, hey, this is too difficult to solve. Too many variables. You cannot really provide a trusted warning that people can actually take action. We decided it's important not to try anyway, when that's what we do. And by the way, I have yet to see a problem that is too difficult to solve. It's a question of how much effort you need to put into that.
Yeah.
Can we use machine learning in the cloud, build some models, simulations? And I asked actually an engineer to show me some progress. And once he showed me some progress, I said, would they need to run a pilot? And within a couple of months, he actually ran a small, in India term, pilot covering about 1 million people. And we saw that we can actually do some modeling prediction, started to see enough science that we were brave enough to publish a paper in NERV's workshop with a hypothesis that we would be able to scale it with machine learning and other techniques. And we started iterating, expanded the pilot times 10, covered all of India at some point, and then pushed the science enough to actually publish a paper in Nature about a global hydrologic model, which could benefit from all the data that we see globally, even benefit areas that do not have data that you can train models on. That enabled us to scale. And today we have flood prediction in 150 countries covering 2 billion people.
Wow.
Up to 7 days in advance.
Wow.
This is life-saving.
Yeah.
And this is for a problem that was considered impossible just a few years ago. But even then, it still hit another wall, because this was for river and floods where, flood is going ahead, river going over the board. And this was not helpful for flash floods, which are also devastating, as we've seen the last couple of years. And there were no good data set on which you can build machine learning models. In fact, the innovation here came recently we published a technique we call ground source. And the idea was taking Gemini, using public data, because flash floods, at least in cities, urban flash floods are reported in the news. So we said, let's take Gemini, apply to all the public data that we have, and try to distill from that flash floods events. And we did it. We actually constructed a high quality data set of 2.6 million flash flood events that we could feed into a machine learning model and build a prediction model. And now it's actually in operation. So we now have flash flood modeling, at least an important step towards that based on the ground source. And again, iterating on this magic cycle, pilots and research papers and more research and building a system and partnering, by the way, with others. We're partnering with the WMO, meteorologists teams on those countries and making it available. And now it's part of Earth AI. Just a few months ago, I had the government of Nigeria actually using the API to actually see where flood is going to hit and send money to villages ahead of the flood so they can evacuate. And similarly, we had partnership with Give Directly, again, who send funds, resources to villages so they can actually evacuate ahead of time and keep themselves safe, as well as take actions to protect their properties. This is an example of something that just a decade ago was kind of out of reach, with a kind of approach of technology, of research, of building systems, of partnership. We made it something that actually can now be beneficial for society.
Yeah. This is beautiful. There's many more examples to talk through, which I'm excited about. But actually, maybe it's worth just like opining for a moment. I feel like in the current climate that we're in today, I think there's lots of potential disillusionment about AI, and it's like, why are we actually doing all this work? And I think this is such a great reminder of like the point of building this technology is so that you can actually do things like this. And I'm curious for your perspective, like being close to like obviously like a lot of these really difficult problems, but hopefully at the end of a lot of research and hard work and all the stuff that happens, the outcome for end users and folks in the world, like how do you think about this moment that we're in and the feeling of AI being used for good and to like actually push humanity forward?
Yeah, obviously AI is transformative. It's touching all aspects of society. And by the way, some of these disruptions require adjustments, require us as a society to think through what does it mean for us? How do we actually make sure we are supporting, we are effective on the fact that many jobs are actually impacted, changed the nature of what can be done.
Yeah.
So the question in my mind is always, how can we build on that? How can we empower? How can we amplify what people are doing? And to the extent that we can, how can we amplify human ingenuity with AI? With doctors, for example, I mentioned MedGemma, which is applying others, but we're not new to the space. We've been using AI now for over a decade. In fact, the paper that was published in one of the leading medical journals, JAMA, a decade ago on AI, pre-Gen AI, of course, this is 10 years ago, the paper showed that AI can actually do screening for diabetic retinopathy in a power of experts. Diabetic retinopathy is a preventable condition that could lead to blindness if not treated, but it's preventable if it's identified. And there's shortage of eye experts to actually do the screening for the many people actually that could suffer from that. And the paper showed that we can do that. In that case, the magic cycle, by the way, took years in great partnership with some experts in Thailand and India. And we even published a paper in Nature Medicine about the process itself of what have we learned. But the reality is that, just 2.5 years ago, I was in Bangkok in a clinic seeing how patients sitting in front of a camera and getting results in just 2 minutes.
It's crazy.
Just 2 minutes. And it turns out that actually the power of AI integrated into this system and empowering the healthcare workers is tremendous, and its impact even beyond the accuracy of the technology. The fact that they actually got the result before leaving the clinic meant that most of them would actually follow up on that. Whereas previously they got it after a few weeks, many would not follow up on that perhaps.
Yeah.
So this is an example for something we've been doing for years, and similarly we just published 2 papers actually in Nature about study we did with NHS about how to use AI for mammography as a second reader in the UK, showing that AI could actually help identify 25% of the misses and bring back about 40% time to the radiologists.
Yeah.
Again, an opportunity to actually get it into that. On healthcare, there are more ways we can actually look into how to help out. For example, we have a sequence of work looking into how to make language models better for healthcare, actually starting with our paper on MedPalm that for the first time showed you can actually have a language model answer questions for medical style exams in a passing score later in an expert level. And iterating on that, talking about Magic Cycle, by the time we had our next paper, we already had partners such as HCA using language models to test out end-of-shift reports for their nurses. And this is the pilot that is ongoing. Actually, I was just visiting their innovation hospital just recently, actually seeing how they expand that pilot. And looking into how to use generative AI to help out with healthcare medical diagnostics in a project called AMI for Articulate Medical Intelligence Explorer, where we're looking into how AI can actually empower in having a conversation, something that we tested out in various stages. And now actually already started the pilot with Included Health to actually see it in the clinics to see if this can be helpful and how we can actually make it more helpful. So these are all examples of how AI can actually help transform healthcare. And healthcare is one of those areas that is so much information based that we have huge opportunity. And we recently learned that actually adoption of AI in healthcare is about twice the rest of the industry. So things are progressing in a very good way on that front.
Yeah.
When we think about healthcare and we think about other science areas, then one area that I'm particularly excited about is how we are actually accelerating scientific discovery itself.
Yeah, I love this. Let me just give you my very quick preface on this. We just came from Google I/O. We're sitting across the street from Shoreline. My hope, and it's on you, it's on teams across GDM and others to deliver on this, is that I/O 2028 maybe is us getting on stage just announcing a bunch of major scientific breakthroughs because of AI, using our products, it's using our models, et cetera. That feels so within reach, and I feel like that sort of is going to be the delivery and ultimate manifestation of hopefully where things are going. And maybe 2028 is too early, but I think there will be a moment, hopefully before 2030, where that is literally what the Google I/O event is just a bunch of people announcing scientific breakthroughs and discoveries, when I think is going to be so cool. And so I think hopefully co-scientists and a bunch of the other work that we're doing will be a core part of actually making that possible.
Yeah, first, let's start with scientific discovery itself. It's obviously something we've been investing for over a decade now. Think about our work on genomics. We had this early work on deep variant, deep consensus, using AI for genomics research in multiple ways, and having partners actually leveraging on that. And we continue, of course, doing this work on connectomics together with Harvard, how to analyze the structure of the brain, work that we're doing with Princeton and Hebrew University and other universities about how to understand the signals in the brain, the functions in various ways, comparing it to LLMs. One thing that we're actually investing in, really excited about, is how to use generative AI to help accelerate the scientific process itself. Two efforts perhaps to discuss is one is AI co-scientist. Another one is ERA, which stands for Empirical Research Assistance. And by the way, last week, for both of them, we actually had 2 Nature papers on these projects.
Yeah. Actually, really quick, for folks, and I should have said this before, for folks who don't sort of understand the prominence of Nature, can you give just the really quick context of why is Nature and publications important?
First, it's important to note that when we're talking about scientific research or research in general, one thing that is more important than ever is the scientific method.
Yeah.
In fact, arguably one of the biggest success of humanity is creating the scientific method where we can actually build innovation and knowledge and then have it validated by the community, the scientific community, in a way that we can actually trust to build on that, to build the next layer. So science and research is this pretty amazing, if you will, cathedral of knowledge built layer by layer by layer, right? I mean, I think it was Newton who said, I'm standing on the shoulders of giants.
Yeah.
That's actually what science is about. It's about building this cathedral of knowledge, these layers of knowledge. In order to build those, you need to actually have validation. That's why peer-reviewed publications are significant. So you can actually trust that what has been discovered doesn't only look good, but it was actually validated to the extent possible by the experts in the field. When we talk about the more prestigious, if you will, publications such as Nature, then obviously the importance is that it tests the merit of the scientific results in a very rigorous way, both in terms of its contribution to science in terms of the validation of the claims made there, to make sure that experimentations were done in the right way, etc., etc. So that's why these scientific milestones make a difference, especially in time that you have so many publications out there.
Yeah.
Very much related, when you think about the proliferations of publications, and by the way, not only peer reviews, I think that publications in archive is one of the amazing phenomena that we see in recent years. The fact that you no longer wait for the innovation until it's actually appearing in a conference or published in a journal. Sometimes it will take months.
Yeah.
Whereas somebody actually, they have the result whenever it's ready to share, they just put it out there and it can be shared. Another acceleration of this, both the research cycle, if you will, but also the magic cycle of research between identifying, learning, and applying it. But it's also created a huge challenge, because with these proliferations of papers, if you're a scientist, how do you actually learn about everything which is going on? How do you actually deal with all this literature? How do you actually build on that for the next one?
I feel like it's impossible. Like, is it not? Like, or it's
Well,
very difficult. It's
For
very
a human, it's
for
impossible.
a human.
So of course we're doing our best on, every person with their own techniques of how to try to get a grasp of what's going on, and reading as many abstracts as possible, or at least as many titles as possible. And here enter one of the capabilities of a system that we call AI co-scientist, which is asking ourselves, can we use AI to actually help us with first literature search, sifting through all the literature out there for any research question that I'm posing. So I want to have some drug repurposing for a particular condition, and I want to scan, I want to read the entire literature that may be relevant. By the way, importantly, not all the relevant literature is obviously relevant. Sometimes you need to actually read through to look for those hints. Also importantly, sometimes the literature that is relevant for your research is from not necessarily only your domain. And in fact, quite often the magic happens when you bring together insights from multiple domains, which is quite difficult to do in real life.
Yeah.
Because especially among scientists, people are encouraged to actually be experts in one area. They need to, in order to be the front line. And then when you want to connect disciplines, it's actually quite difficult, and there aren't too many polymaths out there, in the state of the art of more than one discipline. With AI co-scientist, which is a multi-agent system that is meant for a given research question posed by a scientist, to do literature search practically as vast as needed. But then importantly also, given the question, the research question, start creating hypotheses, generating hypotheses that are relevant to that question. And then once you can start doing this hypothesis, obviously you may have plethora of hypotheses. So an important question is, how do you actually filter? How do you actually decide which ones actually are worth exploring? And also how we rank them. Because, it's like search results. It's not only about how many pages you find, but what are the top 10 for consideration for the scientist?
Yeah.
So ranking is important. Validation, of course, is important. Here's an hypothesis. To what extent can I see that it's actually consistent with literature that I find? Co-scientist is doing that. It's actually doing the literature search, it's doing the hypothesis generation. So think about it as a virtual lab that is actually doing all this work that typically a very senior researcher would do for more junior researchers, helping them, grad students, postdocs, and others. And what we found out is that this can actually be a huge acceleration for science. So in early partnership that we had with Empirical College, they were studying certain bacteria for years. Actually, it took them almost a decade to come up with a certain hypothesis. They didn't publish it yet. And then with AI co-scientist, they got the same hypothesis
That's
in
crazy.
just a couple of days.
It's crazy.
And importantly, AI co-scientists also presented additional hypotheses they were not considering. And I was speaking with Thiago, the professor in Empirical College, who were actually interacting with the system. I asked him, so how was it to work with the AI co-scientist? And his response was, well, it was like working with an amazing collaborator. And a similar response, we have this from our partner in Stanford. We're looking into liver fibrosis, and other partners on drug repurposing and other areas. So we have multiple actually research partners. Some of them already published actually papers based on research that was made possible with hypothesis generation.
How much of this like like the hypothesis generation sort of moves? I had a conversation with Jeff Dean the other day about sort of like where the bottlenecks move to, and it feels like if you can sort of do hypothesis generation with high fidelity, the bottleneck moves to this like verifiability loop. And so I'm curious, like, is if we've seen more traction in domains where like computer science, where like you could actually like do some of this validation, or some other domains like that. Have we seen any early signs of that?
In a world where you can actually generate hypotheses, and some of them, by the way, are very novel hypotheses,
Yeah.
again, should not come as a full surprise given that the amazing milestone of Move 37,
Yeah.
where so that you have when you have a powerful AI that can actually sift through opportunities and try to find something that could actually be good, some of that is going to be extremely novel. A lot of the effort is going to move into validation and into actually also asking the right question, evaluating alternatives, because we typically tend to ask ourselves, here's a question, what's the answer for the question? In reality, really an important area of the research is not only answering the question that is being asked, but also come back and say, you know what, but if I change the question a little bit, here's a much, much better answer.
Yeah.
So being able to actually applying the judgment about the questions, about the interaction, about the validation is becoming increasingly more important. I think that AI should play a role also in that. In fact, if anything, the scientific method is more important than ever, and applying it in a very rigorous way is actually more important than ever, because we cannot afford actually having papers or anything that is not validated. We're in fact looking into how to use AI to help out with some of those capabilities. We have this experimental tool called Paper Assistant Tool, PAT, that is about getting a paper actually providing back feedback to the authors. In fact, we worked with 3 major conferences, ICML, STOCK, and NeurIPS, making it available for authors before deadline. And we had about 10,000 or so uploads. And many actually came back and said, hey, this was really helpful. It actually identified a gap or actually suggested another experiment to run to make the paper better. So this is a step in that direction, but I think there's going to be more opportunity and need in order to have this kind of validation. It's going to be extremely important for these kind of efforts.
Yeah.
If I think about the eco-scientist and other tools, think about a world in which everybody can have their own virtual lab. Everybody means including junior researchers, including postdocs, including grad students.
Yeah.
Think about a future where every person could have their own virtual lab doing this literature search, hypothesis generation, good hypothesis validation to some extent. At some point, they're going to be connected perhaps to lab experimentation that is going to even do more validation in an automatic way. This actually opens up some opportunity for everyone to ask bigger questions, to move faster, and to do that earlier in their career. Of course, there's some work to be done, because if you ask yourself, if you're a junior researcher, do you know how to actually run such a virtual lab? Well, we still have work to do in order to train people to actually build on these kind of new capabilities,
Yeah.
which is true also for software engineering, as we know, and many other areas. So there's more work for us to do as society, as academic communities, in order to prepare for the world in which actually everybody can be empowered to actually do this kind of scientific work in an accelerated way.
I love that. I forgot to mention the punchline of my hope for 2028, or hopefully before 2028, we have these major scientific breakthroughs announced at I/O, and I think specifically it's going to hopefully come from Stanford and Harvard, and all the great institutions will be doing important work. But I think the coolest thing will be if it's coming from folks who we would not have expected. It's going to be like a cure for a major disease. Theoretically, that's like not from somebody who like had 50 years of experience, or like with a team in a domain. It's going to be a random grad student, master's degree student in Iowa who sort of has had a bunch of ideas and it somehow worked out.
Definitely so, because what's really happening is that when I think about AI empowering or amplifying human ingenuity, it actually takes various aspects that today we expect actually every person to have all the knowledge and the capability to actually solve all these items in order to even participate, to have a seat at the table of research. The world expert with the best intuition about a particular scientific domain may not necessarily have all the other skills necessary in order to actually build these models.
Yeah.
Which brings us to another important innovation. Because if you think about the scientific process, even once you have a hypothesis and when you want to actually test it out, or you want to actually test out correlation of, say, COVID events and other factors, these are all scientific problems that require building models. And building models, as we know, is actually very tedious work. It's actually something that can take days or weeks or months, and improving on them, finding a better fit and all of that stuff is something that not everybody can do. So this notion of how to actually build those models is an important aspect and increasingly important part of the scientific progress. And here is where ERA, or empirical research assistance, actually can play a hugely important role. ERA is really about if you have a scorable problem, namely a problem that you know what you're trying to compute and how to measure that, and you have the input. ERA is about how to actually do this kind of search and tuning of models to try and solve it for you. So ERA can actually replace work that could be weeks or months or longer to actually try to complete. And when we build it up, and it can search through thousands of different models or parameter space, etc., and actually give the result to you. And we already actually had just ERA, again, was published in Nature last week. And but at the same time, we also shared about 8 or so new papers actually that were enabled, made possible by ERA in various domains, anything from cosmology to epidemiology to engineering to economics, which is empowering actually to accelerate this kind of research. So now we have this hypothesis generation, and now we have also this ability to have model discovery with ERA, and also we have AlphaEvolve that was created, amazing tool at Google DeepMind. So we actually announced last week Gemini for Science, which includes these tools, hypothesis generation built with a scientist, computational modeling, a discovery, computational discovery built with ERA and AlphaEvolve, and also literature insights built with NotebookLM. So these are all tools that hopefully will accelerate scientific discovery. And now just imagine a world where you can have anybody who's passionate and learns about the topic and they want to actually drive research on that. Of course, the opportunity to be a researcher is even greater than ever, because now you can ask bigger questions.
Yeah.
You can actually have a virtual lab helping you. And once you want to actually build models, you actually have this computational discovery to help you do that. Quite often, the magic happens when you bring in different disciplines. The beauty is that when you think about these AI co-scientists, it's not only having this amazing collaborator, but you practically have a polymath in your pocket because it actually reads through literature across all disciplines. That's quite powerful.
It is. It's a good tagline too. I feel like AI co-scientist, a polymath in your pocket is sort of catchy. I like it. I like it.
Yeah, where did I get it, right?
Yeah, I think there's actually still a big gap between an interesting hypothesis and like starting to get early signal. If you don't know, if you're not in a place where you have access to those types of resources, do you think we'll actually build, or someone is going to like build out the physical infrastructure in order to like do that in a more scalable way?
Yeah, I think that the world is heading towards automating many of these areas that can then accelerate stuff. So various labs. I mean, obviously in the world that you can actually generate hypotheses faster, the economics actually make sense to actually have labs that can actually then test things faster.
Yeah.
Right? I mean, that's becoming the bottleneck.
Yeah, for sure.
So I'm sure we're going to see even acceleration on that one.
We need this from GR. We need physical labs to make this happen. Cool. Well, let's talk then about all the architectural improvements that are coming out of GR, interesting, novel model techniques. We were talking before about like speculative decoding, and we should describe what it is for the audience and maybe for me as well, to sort of go through the details. Generally, that whole class of like, it's not just science, it's not sort of like the applications, but it's also actually like fundamentally like model techniques to improve Gemini and everything else that we're doing.
Yeah. So first, perhaps if we can take the overall view for what we're looking for, what kind of problems are we looking at? Obviously, a lot of what we do is actually helping transform Google products for the benefit of its users. And this applies to search, YouTube, Geo, Cloud, and of course, Gemini. And working very closely with all teams at Google, who have a lot of collaboration with Google DeepMind, Cloud, Search, and so forth. So these are actually an inherent part. And part of the magic actually working at Google is to work across organizations, both on the research side as well on the side of actually bringing it to reality.
Yeah, we need more GR AI Studio collaborations. That's my pitch. So we
Definitely, we
talk offline. We can talk offline.
We should definitely do that. We should definitely do that. In fact, we're looking into GR Lab, this
Yeah,
off script.
I love it.
Yeah. One of the big questions, of course, with generative AI is how to actually drive research on foundations of Gen AI. Some of the obvious questions are how to make them more efficient, how to make them more factual, have them in multiple languages, and so forth. Perhaps we can start with efficiency, because
Yeah.
efficiency it's funny because, as a computer scientist working on algorithms to make things more efficient has always been one of the, the holy grails of things. Obviously, with Gen AI, it's becoming more important than ever. It has direct impact of what we can actually do there. A couple of years ago, we actually developed this algorithm called speculative decoding, which looked into how to actually accelerate the inference in LLMs. And what we found out that you can algorithmically, in fact, double or more than double the efficiency of the inference, and the efficiency here is both in terms of latency and throughput, and without any loss of quality.
Hmm.
And somebody said, "Hey, there's this no free lunch principle." I said, no, with algorithms, actually, that's where we're creating free lunch. That's what we try to do. And it helped us actually accelerate our products right away and actually save a lot of computation. In fact, practically it became industry standard. So one can actually argue that today the entire world is running LLMs as if we had at least twice the chips,
Yeah.
just because of technique and its variants. And there are many innovative kind of variants of speculative decoding. So that's an example of actually how to use algorithms to actually, accelerate, and then of course have it applied to products and obviously to models.
Yeah. What about sort of new architectures? Is that also something that y'all are exploring?
So as much as I'm excited about having twice the performance, and actually recently there was a team who actually applied it to Gemma 4 and got the ×3 performance.
I think I saw
So
that. We published this, right? Yeah, I
Right.
saw this.
So as much as I'm excited about it, I'm still waiting to see the ×10 or ×100 improvements, algorithmic or architectural. So obviously looking into various techniques and research to see, how can we accelerate stuff. And by the way, looking for that from the entire community. So innovation, novelty can come from everywhere, and I don't see a reason why we shouldn't see a step function at some point of efficiency just by algorithmic or architectural modeling approach. And certainly we're doing our own share to look into how to actually accelerate.
Yeah, I love that. Through this conversation and through when we were talking off camera, I think the thing that is so interesting about GR is it really is the full stack of it. It's everything from making inference more efficient to doing foundational research to actually how do we bring new sort of product UI experiences to customers. And so I saw you mentioned before, I had a conversation with Robbie and the search team about GenUI, which is actually something that your team worked on. So do you want to sort of give context for folks who?
I mean, it's hard to believe that it was a year ago when I had a conversation with Robbie about how do we actually bring it to search.
Yeah.
And here you go. GenUI is one of those examples where you put a small team, you ask them to come up with, let's come up with some crazy ideas, and you see a demo, and wow, it's about how to use generative AI to not only create the content, but also to help decide, given the content, what is the right presentation of that content that will actually make it most effective.
Feels like a very Google problem. This is showing the world's information.
Right. Totally. So, and again, another important thing is not only a brilliant team coming with a brilliant idea, but then also using AI to accelerate, to do the demo quick, and then to implement it very quickly.
Yeah.
And then to actually have it out both in search and Gemini and build on that. And many of the announcements on generative UI in search and Gemini app actually are based on this foundation of this demo that was actually iterated on. So again, this is an example for a magic cycle of actually coming up with the research, with the prototype, iterating on that, solving a few more problems along the way, and then applying it to reality. And now we have a new experience of actually consuming content with AI actually helping us with the presentation itself.
Yeah, I love that. I feel like that also has to be one of the, or I'm curious actually where it stacks up as far as you mentioned before this, the magic cycle is getting faster. And I feel like Gen UI is maybe one of the fastest examples. I don't know if there's been something faster, but probably the order of like months to like actually getting it into some of these experiences, and then like more widely rolling out at I/O this year, and actually more widely rolling out a few months ago, and when Search announced it. So crazy.
Well, actually, it rolled out within months, actually, of the
Yeah.
first kind of, if you will, publication, or a first kind of demo. And then within a year, actually, we have now a large scale. So I think that this acceleration is there. So again, a combination of innovation, very strong technical kind of capabilities to actually move things, and of course, the drive to actually make a difference here. So this is a good combination.
Yeah, I love it. Yossi, I feel like we could have this conversation, or we will actually have this conversation every couple of months, because I feel like GR is touching so many different things across Google that I think you have a very interesting perspective, like seeing all the things that are happening.
On a personal level, my interests have always been both on driving research, and again, I had the opportunity to be in Bell Labs in their heyday in the Mathematical Center, where Shannon and Hemming were there many years before me, and Paul Erdos was actually visiting us every year. At the same time, my passion is really about how to build products and have impact. So, over the years, I was actually going back and forth between scientific research and entrepreneurship, building products. And at Google, actually, much of my time, in fact, over a decade, I was at Google on the search leadership, building products in search, Google Trends, autocomplete, and so forth. We are in this amazing time where actually this notion between driving the research breakthroughs and then applying them to products and working with product teams is tighter than ever.
Yeah.
And
You should do some like writing about this. I feel like I'm not sure. Like I think you're spot on with this, and it's not clear that like the broad ecosystem like really is like grokking this point, and it's like so worth like double clicking on that.
I totally agree, totally agree. And in a way, for example, I never use the term technology transfer. It's never about the transfer.
Yeah.
It's really about identifying the problem, solving the research, applying it to reality, and circling, because it's never one time, it's never one directional.
Yeah.
And that's actually where the magic happens. It's really this iterative approach on improving on all things. So personally, since in fact, even when I was in Bell Labs, by the way, my best known theoretical research was motivated by real world problem, which happened to be what was then the largest data warehouse in the world, and actually then helped create a field for data streams that practically enabled big data analytics. But it took years actually to do this kind of cycle. And now actually part of our job is actually to do both. And one of the strengths of Google Research is actually in this doing this actually both. Same team that actually pushed the research on floods is the same team that actually built a system that is now providing prediction to 2 billion people. Same thing, I would ping actually what's going on in that place. Same thing is thinking about the next project. And as a fun fact, I recently had a conversation with one of the research scientists there, and I learned that he was actually looking into a particular model that he, for a long time, was unable to make progress on, and then with ERA, he actually made some good progress on. So it's all connected. Let me give another example for research we've been doing for several years. In fact, when LLM just started back in 2021, we actually started looking into research on factuality for LLMs. And again, part of what we're trying to do is to not only think about the problems that everybody care about today, but to take bets on what may be important in the future. In 2021, very few people actually cared about the future of LLMs, factuality, but we actually thought, I thought that factuality is going to be more important than perhaps anything else if we ever want to use LLMs.
Yeah.
So in fact, one of the pioneering papers on factuality for LLM was published by our team in collaboration with academic collaborators back in 2021 about measuring consistency of LLMs. And even in 2022, we already had a benchmark out published. We called it True. When we started putting out our language models, we started actually taking some of our research and applying it to our language models, and to BARD and others, to PaLM and other models, to Gemini, of course, and keeping on the research and iterating on that, and then working very closely. Everything we do, of course, on Gemini is a very close collaboration with Google DeepMind. So working with the teams and actually bringing together factuality research into making Gemini even more factual, publishing the fact leaderboard that so it's to encourage actually other models to also test themselves against benchmarks and keep iterating on that. So this is an example for a magic cycle that has been going on since 2021 on the factuality of LLM. And is in any given moment, I would say that, hey, in fact, much of the work is still ahead of us because factuality of LLM, in order to trust large language models, we really need to know that it's working to the best possible. And the better it is, then our expectations are going higher and more nuanced. The nature of factuality is changing. It's multimodal. It's taking context into account. It's addressing also more nuanced questions. In fact,
Agentic, it's sort of doing things on our behalf.
exactly, it's
Yeah.
agentic. And by the way, one of the areas that I think is extremely important is also for not only the question of how factual things are, but to what extent do we know how factual we are? What's the level of confidence? That's an extremely important aspect from my point of view about the factuality of LLMs or any system for that matter.
Yeah.
The beauty of technology is that what is only possible for very few in very few years becomes a commodity. Let's call it technology commodity
Yeah.
or scientific commodity, because everybody can now use it or build on that. It's like nobody thinks that there's going to be self-driving cars. It's an inflection point that's only boom.
Yep.
Everybody,
20 companies.
of course. Not only that, but look into what's happening on the street with Waymo, which
Yeah.
is amazing. This
Yeah.
amazing success of the Waymo team.
Yeah.
And again, it wasn't that long ago that people were skeptic.
Yeah.
So the
true.
beauty is that technology innovation and scientific progress is not linear. That's actually a common mistake. People are extrapolating. That's what we're doing again the mistake. In fact, going back to Google research, our job is to look into the horizons and around the corner. It's not to extrapolate. That's why quite often I would take bets. And that's part of my fun is actually, I started actually doing AI. I did duplex. You remember duplex?
I don't think so.
Google
no.
duplex?
No, it sounds super familiar.
Google duplex was the big announcement in 2018 of the AI system that's called the restaurant reservation.
Oh, yeah.
And
I
sounded
do
like a
remember
person.
this. I do remember this. Yeah.
The biggest AI moment in 2018, arguably.
Yeah.
So this was my pet project. I was actually in search at the time.
Yeah.
But at the time I thought about, well, in the future, actually conversational experience is going to be the most important one. So we should actually look into that. And the question I was asking there, are we going to get to a stage that everybody can just talk to the computer? This was the question I actually put publicly in a talk in TEDx, where I was actually saying, hey, can we actually just talk to a computer like we talk to ourselves?
Feels so common now.
Yeah, and my answer was, yeah, I think that anything that if we can dream it, we can build it.
Yeah.
So, and again, today, if you ask anybody, of course, yeah. I mean, yeah, of course I can take a Waymo, and of course I can talk to my computer.
I tweeted this morning actually that in the age of intelligence, sort of like you can outsource your thinking, but you can't outsource your understanding. There's like this conflation between the two things that I think is actually going to become ever more present. And that's why I'm like even more excited to hear about sort of what's top of mind on education.
So, when I think about a few years ago, somebody asked me, hey, if you had a magic wand for helping climate, but you cannot just use it to fix climate, but use it somehow, how would you use it? And I was thinking about it, and my answer was, well, I would actually use it in order to make sure that we're getting the right education for every kid, because they're actually going to solve all the other problems.
Yeah. Yeah.
So obviously, having the right education is the single most important thing for any society. Obviously for societal reasons, but obviously also because that's actually the most important resource that we have, this human ingenuity. And with AI as a possible amplifier of human ingenuity, that becomes a multiplier. So the question is, how can we actually do a better job in education? And also, how do we need to change it, given what's happening, right? With AI, it's actually enabling new capabilities in education, but also creates new objectives for us, how to actually educate the next generation so we can actually use AI. AI is not something that happens to us. It's something which we should build on.
Yeah.
And same applies for education. Like in any system, the first question is, how can we build models that are better suited for that? we did work on LearnLM, which essentially is how to adapt model so that it knows that it can support various needs for education, such as, for example, releveling, such as quizzes, basic stuff for education. And we actually made it eventually part of Gemini, and now you can have applications built on that can leverage on the capabilities. As an example, I was visiting a high school in Ghana where a teacher was using an app developed by a third party, actually built on leveraging and LearnLM. And they told me, hey, now students are getting response to assessments every day instead of only once or twice a week. And the teacher got back 5 hours.
Yeah.
So obviously, this is about how to make things more efficient. Now, when you think about it, and we did some efficacy studies and looking into other ways in which you can actually use it. But when you really think about it, the real opportunity is for using AI not to just make things more effective, but actually to change things. Why can't you have assessment that is more personalized, that is real time, as if you have a tutor sitting next to you and actually tapping you on the shoulder every time you need to do some correction? That's actually the real opportunity. Another comment here is that the role of the teacher is more important than ever. In fact, a few months ago, I spoke about AI for education in a conference, and then I actually pointed out that, I'm forever indebted to my own high school math teacher, and I was actually fortunate to have him in the audience, actually there, to be there. And the role, every one of us have their own, teachers that influence their lives. Yeah. How can we actually make it even more so for everybody else who perhaps didn't have those teachers? And to me, it's really empowerment. It goes back to how do I use technology so we can empower the teachers, so they can actually focus on being the inspiration of actually making those change.
Yeah.
Another important comment is that when we think about how to use AI for systems, the first thing is how to make things more effective. I would say how to amplify human capability, if you will. That's only the first step. The more important impact is how to do things that previously were not possible to do. That's really the amplifying of human ingenuity. And that applies to education, it applies to doctors, it applies to scientists, it applies to all of them. So when I look into education, really the question is how do we first make sure that we can empower teachers with technology? How can we make things more effective? For example, you have this experiment called Learn Your Way, which essentially asks the question, how can we reimagine textbooks? Can we take textbook and actually make it in multi-modalities and in a way that is personalized? How do you teach gravity for a girl who's 10 years old and loves soccer? You do that differently than for a 16-year-old that loves tennis.
Yeah.
So these are opportunities to do. We're also looking into how can we actually have programs such as AI Quest, which is working with, we're working with Stanford Education Center, how to actually expose kids to the opportunities of AI. Think about it as AI skilling. Talking about skilling, one question that I think related to your comment, what are the skills that are most important for the future? So we can debate to what extent they need to learn the basics. Personally, I think that, for example, thinking how to code, basic computer science, etc., is going to be more important than ever.
Agreed.
I mean, I always thought that computer science is not learning a language; it's
Not
learning
typing
how
keys,
to
it's how to think.
Yep. So in a way, it's going to be more important than ever, for the same reason that math is important even when calculators became a commodity. But obviously, there are skills that are going to be more important than ever. For example, collaboration. If the role of the person is going to be more importantly to ask the right questions and to validate the answer and to ask what is good, it means that certain humanities and certain capabilities that perhaps sometimes we call them soft skills, but they're actual skills. How to collaborate is a skill.
Yeah.
These are going to be more important than ever. So how do we teach them? In fact, we actually launched an experiment called Vantage, where we're actually trying to measure those skills, this collaboration with NYU. And we put it out as an experiment to see, can we actually look into how to measure it and how to actually practice that and how to skill it? To me, these are important areas that we need to actually double up on in order to see how do we teach the next generation the right skills for a future? How do we keep making sure that they are learning the basic skills? Because when you think about AI becoming a kind of a tool for everybody to build in, we need everybody to actually be elevated
Yeah.
so that they can actually use those tools. It's true in science to run your own virtual lab. If you think about it, you need to do the stuff that you need to be very advanced scientist to do that. If it's a teacher, to actually build on that. If it's a business person, etc., etc. If you're a healthcare worker, essentially to be able to operate as if suddenly you have this kind of capability in your hands. So I think this goes back to education, to the early questions, and education across all ages. How do we actually give those skills? How do we empower them? And how do we use AI in order to do a better job at that?
Yeah. Even upskilling folks who are sort of like not in the traditional education system, I think is really interesting. Like I was just thinking as you were saying that, I barely eked my way through calculus. It was very difficult for me for whatever the reasons were. So things didn't click in many ways. And so one of my like personal benchmarks is like I want to go back and like try to like from scratch learn and see how long it would take. Like actually using these tools, using a lot of like actually Notebook LM, I think is one of the products that hopefully a lot of the research that y'all are doing ends up making its way to, and just like personalizing the educational experience for people based on what they get excited about. And that was always my challenge, was like you sort of learn a lot of these things in a vacuum. And even actually computer science, like you learn computer science sort of and there's like a distant hope that you maybe will do something that's interesting. And I feel like what's gotten me excited in the last couple of years about what's happened with software is like the distance between the exciting thing, you can sort of like taste it now and you can feel it and you can experience it. And I feel like in math and other disciplines, it like wasn't like that. You had to get so far down the path in order to like experience it. And I feel like it's been cool to see that change and hopefully get people more excited about doing that type of stuff.
Yeah, I mean, if you think about it, a few observations is those who actually got the right tutor and the right teacher, then they actually got this opportunity to do stuff that others perhaps not.
Yeah.
Now, I think that human capability is perhaps one of the most, this is the most important resource that we have here. How do we actually enable everybody reach their own potential is an opportunity that we have here. And on education system, you're totally right. I think my own experience, even as a tutor, I remember when many years ago I was actually tutoring kind of bright kids, and I couldn't understand why they are actually failing in math when they're so bright. And actually, after a little kind of investigation, learned that actually they have a gap to fifth grade math, which they were carried on all the time, and it was actually all the time in the way of actually doing things the right way.
Third grade, I got my appendix removed and I was out for a couple of months, and I'm sure that that's what it was catching up to me in calculus.
Now, all these matters are fixable if you have the right attention and the right time. Hopefully, with AI, we can actually fill many of those gaps.
Yeah.
That because some of them are actually not too sophisticated if you put the right intelligent reasoning on them. And I think with AI, we can actually get pretty good reasoning to actually address many of these problems that today, as if you had suddenly an abundance of tutors, very smart assistants helping you, research assistants, if you will, helping you on practically any topic. So I think that's actually some of the opportunities that are opening up. And again, going back to what our role in that is really to think about some of those opportunities and to build into some of those, to the extent possible, work with others. So I'm quite optimistic about how we can actually make a real difference here on things that really matter, really having societal impact on those.
Yeah. You mentioned before we won the Nobel, a bunch of the researchers won the Nobel Prize for quantum. That shined a light on a lot of the breakthroughs that have been happening, but folks who have heard bits and pieces, maybe thinking quantum is science fiction. What is Google actually doing today in this space?
So I think quantum is an interesting story, but obviously some of the early pioneering thinking came from Richard Feynman about, making the case of why quantum could be a big deal one day. The big breakthrough was Peter Shor actually showing a real practical algorithm that today is perhaps some people would say too practical, of actually factoring numbers. And this was, by the way, Peter was his office was just across mine in Bell Lab. So
Nice.
and he showed actually with a quantum computer you could actually solve a problem that is assumed to be hard for classical computers. Actually, it's so much assumed to be hard that it's the basis for many of the crypto systems. that are used in the industry.
Yeah.
And he showed that if one day we're going to have quantum computer, we're actually going to be able to solve it. Now, by now, we have actually a dozen or so, perhaps 70 or so kind of known applications of where quantum could actually make a significant acceleration over classical computer. But importantly, there are some additional expectations that if we'll have quantum computers, we're going to be able to actually have a better understanding of materials. We can actually simulate materials. We can have quantum sensing.
What, and for simulating materials as an example, it's just like some of those simulations are just like so computationally intensive that
Not only that, you need to have the intermolecular, you need to have the quantum phenomena. So this was
Got it.
actually part of the statement by Feynman that, hey, in order to actually simulate a quantum world, you need a quantum computer.
Yeah.
This was kind of the thesis. But importantly, my projection is that when you think about what is known that quantum computer is going to have advantage over the world, suppose what will happen if you take thousands of bright people working on actually developing more applications. Because think about all the big number of amazing talent working today on AI and machine learning, and you see proliferation of progress.
Yeah.
Just think about the fraction of that actually working on quantum.
Yeah.
I'm sure we're going to see many more opportunities to actually unlock because it's a new computing paradigm. Now, the real question is then, can we build a quantum computer? And what is the technology to do that? Now, some of the breakthroughs that are enabling that go back to the 80s. And we're really thrilled with the Nobel Prize in Physics to Michel Devoret in our quantum AI lab. And also John Martinez used to be part of that lab, and also John Clark, the collaborator from Berkeley. The three of them were recognized with Nobel Prize from their work on the 80s. Now, we built our quantum AI lab in 2012.
Actually, really quick, why the gap? And I'm not super, I saw the announcement and stuff. Why the gap between the work in the 80s to being recognized in, I think it was 2025 or something? Was it just, it like took that long for it to be like shown actually that like the work was going to prove out, or it had been proven out and then folks just are, quantum's becoming more real. And so there's like more like scientific interest in the ecosystem, or like why such a big gap in that? Or
Well, I cannot speak for the considerations of the Nobel Award Committee.
Please.
But so the big question over the years was, will we able to build a quantum computer that actually can do the work? There are many questions, including one of the big technological hurdles was, in order to have a scalable quantum computer, you need to solve the problem of errors. And you cannot just apply error correction like you do with classical computers. So this notion of quantum error correction is increasingly important. Now, over the years, we did have significant milestones. Our own milestones just last year was actually the Willow chip, which had a couple additional milestones with that. One was an error correction that was tremendously better than previously known, that actually showed a promise that we can actually keep scaling quantum computing with error correction. And quantum error correction, just to double click on that, is really because the basic operations are dealing with qubits, and in this physical world, not all operations actually work. And then you need to somehow compensate for that. So how do you actually deal with faulty qubits? So error correction is helping out to do that, much in the same way that things happen also in the regular computer, and then you use error correction on classical computer in order to compensate for that. We had a few milestones. The most recent one is called verifiable quantum advantage, namely a problem that we could actually apply a quantum computing that we could verify and compare it to the best classical computer that could solve it. And we showed that a particular problem, we could actually do that 13,000 times faster.
Wow.
So this is kind of a verifying in a problem that is different than a mathematical Shor algorithm, that, hey, there's a certain computation that with a quantum computer, we could actually do it much, much faster than classical. Now, it's still the premise, and we still need to keep building the systems. We had very clear roadmaps of how to reach those. And again, it's a combination of an amazing hardware team, applications on quantum, and we keep actually having these milestones. And the premise there is quite significant, obviously also accelerating AI in some capacities. So it's not going to replace classical computers, but it's going to complement them. And for certain problems, it's going to unlock opportunities never seen before, such as generated data, for example, for which we can possibly build AI models that can help us better understand say, materials or biology information or fusion and so forth. So anyway, these are some of the premises, and really exciting to, to see how we're making progress on that, and how this is actually based on work done in the 80s, but keep iterating on that. So the magic cycle of research here, it takes longer,
Yeah.
but it's quite significant.
There's so much stuff happening. Keeping track of this, I don't know if we put a metric on the pace of the magic cycle and sort of watch as things happen, like the speed up. This would be a fun benchmark. I don't know how to do this, but this might push for you. You should make that. I feel like it'd be super interesting to see.
All the work that I've been talking about is made possible by amazing teams.
Yeah.
That are working together across great collaboration, obviously within Google Research, but also with our colleagues in Google DeepMind and across Google. And a lot of that also with the academic community. So this notion of actually having smart people that are driven by making real impact, working in collaboration, then applying it on some of the best systems in the world, of course, and applying it to products that are actually serving billions of people, helping in so many different ways, and then iterating and thinking about what's next, about what's around the corner, what's in the horizon, how to take those bets that we can actually drive things that perhaps may seem impossible, how to actually make them possible.
Yeah.
That's actually a pretty amazing opportunity. That's why it's really more exciting than ever to do research. It's really a golden age of research.
Yeah, it's very exciting. Well, Yossi, thank you again for sitting down and talking about sort of the golden age of research. I feel it, and I think it's sort of our obligation to help tell the world this story. So thank you again.
Well, thank you. Thank you very much for having me here. It's always great to have a conversation, and thanks for amazing one.
Of course. Yep. And thanks everyone for tuning into this episode of Release Notes. We'll see you in the next one.